Once again, thank you so much, Lana, for joining us and sharing for us. I think everyone here will actually already know of you and know of your paper, but I guess I should do the introduction. So I have your bio. Mana Ryuba is a second-year PhD candidate at the University of Melbourne. Her first paper was recently published in Precambrian research titled Tectonically Induced Neptunian Dykes and Breccias in the Paleoproterozoic Teena Dolomite, Significance to Stratiform Zinc Deposits in the McArthur Basin, Australia. Her PhD research focuses on the sedimentology and geochemistry of Precambrian carbonates to understand surface processes and ocean chemistry of Precambrian Earth. She's currently working on the Maranoan cat carbonates in the Flinders Ranges, Australia. Thank you again.
Thank you. No, thank you so much for having me, for inviting me to talk about this work on these unusual Neptunian dykes and breccias. I think I'll just get started. So I'm going to start off this talk by talking about stratiform lead zinc deposits, and I'm sure that those of you from the Northern Territory will be very familiar with this deposit type, because of course the northern part of Australia is an extremely important region for this type of deposit. So of course these are made of these finely laminated sulfides, commonly hosted in organic rich shales. So I've used the term stratiform quite deliberately because there are a few models to explain how these deposits form. So probably the most well-known is the sedimentary exhalative, or the ZX type deposit model, and the other is the clastic dominant type deposit model. And so you can categorize these two as to be a kind of sedimentary model and an epigenetic model. So the ZX type deposit model is where you have a vent that allows for these mineralizing fluids to reach the surface. So mineralization takes place right at that surface water interface. In contrast, the clastic dominant type model suggests a carbonate replacement is taking place within the subsurface. So this would then occur at depth. So this is more similar to MVT style deposit models. So I'm going to take you to the Batten Fault Zone region for this study. And so this is, of course, the area where we find the famous McArthur River, or the HYC deposit, and also the Teena deposit as well. And of course, the McArthur Basin makes up, is one part of this larger zinc province, also known as the Carpentaria Zinc Belt. So the unit that I'm going to talk about is the Teena Dolomite. So it's that unit that underlies the Barney Creek Formation, and the Barney Creek Formation is the one that everyone is interested in, because of course that's the one that hosts the HYC deposit. So Chris Reed, when he was at Tech Australia, brought this project to us because essentially there were these unusual breccias that were appearing in multiple drill cores, and so Chris wanted to find out what these breccias were and whether they could tell us anything about the mineralization process in this area. So breccias have been previously documented in the Teena Dolomite. So Peter Winefield wrote about it quite a bit in his PhD thesis, and so obviously that would be a sedimentary origin for these breccias. However, more recently, there's been these breccias have been interpreted to be of a hydrothermal origin. So they've been called black matrix breccias, and black matrix breccias are a hydrothermal breccia that is commonly associated with Irish type deposits, so which is more similar to MVT type deposits. So that would be an epigenetic origin for these breccias. So yeah, I just think it's interesting that the story of the breccias seemed to be mirroring that the different ideas for how stratiform zinc deposits form. So we started off wanting to find out where these breccias occur within the Teena Dolomite. And so these are some stratigraphic sections that I put together of the different drill cores. And so this is the Teena Dolomite, and the above is the Barney Creek Formation. And what was interesting was that these breccias seem to be appearing at the same stratigraphic position across different drill cores. So this is suggesting then that this event is well, a stratigraphically constrained event. It's happening right at the topmost section of the Teena Dolomite. And these are what the breccias look like. So they have a range of different textures, and we've categorized them according to whether they're more in situ type textures or transported textures. So we have crackle type breccias, mosaic breccias, and also this matrix supported rubble breccias. But what was interesting to us was actually what was between the class. So the infill of these fractures is what really tells us how these breccias formed. So these fractures tend to be infilled with fibrous cements, and there are several different types that we've described. So this is radiaxial fibrous cement, and this is a fascicular fibrous cement, and herringbone cements. So these cements are indicative of a marine environment. And that's because these fibrous cements form as a result of rapid precipitation of calcite from seawater. And we know that these are sedimentary features because these fibrous cements tend to be overlain with sediment. And so these are the fractures, and you can see that we have those fibrous cements, and then you see those sediments overlying them as well. And you also have these fractures that are just infilled with sediment. And so essentially, when you have a fracture that is infilled with sediment and or marine cements, what you have are Neptunian dykes. And this is important because this tells us that these breccias are forming really early on, so right at the surface. So these are not epigenetic breccias. So yeah, you can see that there's some really interesting textures here again, and you can get a sort of timing relationship for the different Neptunian dike phases. So you can see that there's this white cemented Neptunian dike being cross-cut by these by this sediment one, and yeah, you can get really complicated features, and that's really just showing that we have a multi-stage Neptunian dike formation happening. So essentially, you have the first phase of Neptunian dike forming, where you have the fracture opening, and you have fibrous cements precipitating on the walls, and also sediment entering those fractures too. But so when you have another refracturing event, you have this second generation of cements and sediment infilling these fractures. And then when you refracture that Neptunian dike again, you can see that you could come up with these really complicated textures. So it turns out that these breccias are distributed really widely in the Batten Fault Zone area. And so each of these points here represent a locality where we see breccias and or Neptunian dikes occurring in the Teena Dolomite. So it seems to be quite a widespread event. So where do you find Neptunian dikes? Neptunian dikes are commonly associated with reef platform margins. So they form kind of at the edge of a reef where you might have fractures forming, maybe from some kind of gravity-driven instability. And these fractures are then pumped with the seawater, and from that seawater we have those marine cements precipitating. And related to these kind of marginal slopes, you usually have these debris flows as well. So this seems like a sensible origin for these these Neptunian dykes and breccias. Another way that we can get Neptunian dykes is actually through tectonics. So there's been quite a lot of work done in the Jurassic Cretaceous Tethys rift, and also much younger rifts off the coast of Italy as well, where authors describe Neptunian dykes along being related to extension. And so this is what they look like. So you have these fractures that are being infilled with sediment from the overlying unit. So syn sedimentary fractures. So we do favor this idea of the tectonic origin for the Teena Dolomite, and that's because the Teena Dolomite doesn't really show any evidence of reef frameworks as far as we can see. And also, if you look beyond the Teena Dolomite, we know that there is a regional subsidence occurring because you have that transition from a relatively shallow marine environment in the Teena Dolomite to a much deeper marine environment in the Barney Creek Formation. And I guess tectonically induced subbasins have been a prevalent part in the models for the Teena and the HYC. So this subbasin idea was kind of came up through trying to describe the Barney Creek Formation being at different thicknesses regionally. And finally, we have these debris flows that occur between the ore lenses at HYC. And so this is suggesting that we have these syn sedimentary fault scarps that are during the mineralization. So this is what we suggest. We suggest that the Neptunian dykes and the breccias in the Teena Dolomite represent the onset of an extensional tectonic event at about 1640 million years ago. So we have the onset of extension, which and the seismic activity that's related to this then fractures the Teena Dolomite on these fault blocks. And those fractures are then open to seawater, so that's where you're forming those marine cemented Neptunian dykes. But as that tectonic event progresses, you have a deepening of the basin. And so you have the Barney Creek Formation being deposited. But because we're still having ongoing extension, we're still getting these fractures forming in the fault blocks. And so now those fractures are being infilled with these sediments. So we're forming those sediment-filled Neptunian dykes. But we might have some topography related to this. So in the paleo highs, we might be forming these other generations of marine cemented Neptunian dykes. So this extensional event seems to explain what is happening in the McArthur Basin, but it happens to also coincide with other descriptions of extensional movements in other parts of the Carpentaria zinc belt. So one example is from the Lawn Hill platform. So this is the river event that was described by Scott and others from seismic data. And then we also have some geochron studies and paleomag studies as well in these other parts of the Carpentaria zinc belt. So essentially, this is suggesting that this tectonic event is actually affecting the whole of the Carpentaria zinc belt, not just the McArthur Basin. And in addition to that, we know that the shales, the organic rich shales that host these stratiform lead zinc deposits are all of about a similar age, so around 1640 million years plus minus 10 million years. So there's a list of them. So HYC, Mount Isa, Lady Loretta, Walford Creek. So yeah, this is suggesting then that this tectonic event is important because that's the regional subsidence that occurs as in association with it is the reason why we have this transgressive event. And without that, we wouldn't have the deposition of these organic rich shales that go into to host these important deposits. And additionally, we think that this tectonic event could also form those faults that might act as conduits for mineralizing fluids as well. So I think this also has some implications for how we view the HYC ore deposits. So this is quite a typical cross section that is used to depict what the HYC deposit looks like, and yeah, so this just bringing your attention to this Cooley Dolomite unit. This is a unit that has there's been a few ideas on how what this breccia is, but it's commonly depicted like this, coming off this this western fault. So currently, this Cooley Dolomite is considered to be part of the Barney Creek Formation. So that's the unit that overlies the Teena Dolomite. So, and it's seen to be the lateral equivalent of the HYC Critic Shale member. But Hinman suggested that these Cooley breccias might actually be of tectonic origin. And he also suggested that, that the Cooley breccias were not actually part of the Barney Creek Formation, but may originate from Teena, the Mitchell Yard, and Mara Dolomites. So given what we now know about the Teena breccias, and we know how widespread they are, it seems reasonable to then suggest that the Cooley breccias are just maybe another occurrence of the Teena breccias. And we're quite certain of this because Malcolm, Chris, and Nick recently were able to take a trip to McArthur River and see this Cooley Dolomite. And yeah, from what they've told me, it looks exactly the same as the Teena breccias. So that's really exciting. So that's it from me. But just to summarize, so the Neptunian dykes and breccias are of a sedimentary origin, and we think it represents this extensional tectonic event that's happening at about 1640 million years ago, and that this tectonic event is affecting other areas of the Carpentaria zinc belt as well, and it's probably what's causing the transgression that leads to the deposition of those deep marine cements that are so important for the stratiform zinc deposits. And I think that this study demonstrates the value of looking at rocks that are beyond the immediate ore deposit itself. And if we kind of look at the periphery geological context, maybe we can get a wider context for what's happening for these important mineral deposits. So just before I finish, I want to thank my supervisors, Malcolm Wallace and Ashley Hood, and Christopher Reed and Nicola Kaywood, who brought this project to fruition, and Tech for allowing us access to their cores and facilities as well. And yes, that's it for me, and thank you.